Hello everyone, I welcome you all for this session. In this session, we are going to see case 2 of per unit reactance diagram. Last class we have seen if the impedance values are given in terms of ohms, how to find out the per unit quantities and how to draw the reactance diagram. In this case, the given impedance values are in terms of per unit, not in terms of ohms. So let us see what is the procedure if the impedance values are given in terms of per unit and how to change the base quantities. When the reactance values or you can say impedance values are given in per unit. Draw the per unit reactance diagram for the single line diagram given below. I have considered the same numerical, only the thing here I have considered is the impedance values I have replaced as a per unit value instead of the ohms. So the generator value is 30 MVA 11 kV. X value we are considering here as 0.2 per unit. Motor is having 25 MVA 11 kV. X is equal to 0.2 per unit. Transformer T1 is having MVA rating 15 and voltage is 11 kV by 33 kV, which is a step-up transformer. This first transformer is step-up and the reactance is 0.1 per unit. And transformer 2 is having MVA rating of 15. So it is a step down transformer which is going to step down the voltage 33 kV to 11 kV and it is having a reactance of 0.1 per unit. And the transmission line is having 20.5 ohm per phase. So I have given you two equations to find out the impedance value. If the impedance or the reactance value is given in terms of ohms and what is the formula, and if the reactance value is given in terms of per unit, what is the formula. Okay, here we are going to use the second formula, that is if x is in terms of per unit and if you want to find out the new per unit value with respect to the new base values, now the formula is x per unit new value is equal to x per unit old value into MVA base new value by MVA base old value into kV base old value square divided by kV base new value square. Okay. So if you could recall the formula, that is the formula that I have given if the reactance value is given in terms of per unit. So now let us see what we have to determine in this particular problem. By taking 100 MVA 11 kV base voltage at generator. So now we need to find out the per unit quantities with respect to the new base values. So the first base values we are considering 100 MVA and 11 kV that we are considering with respect to generator. Second condition is 100 MVA and 10 kV at generator. Third condition is by taking 100 MVA and 32.5 kV at a transmission line. Okay. So now let us start with the first condition, that is we are taking the generator ratings as a base voltage. Okay. So not the MVA rating, we have considered the voltage rating with respect to the generator terminals. So now let us take the single line diagram and let us mark the old values which are given in the problem, okay, for all the components. Now based on this we are going to mark the new kV base values. So for that, first let us assume what are the base values that we are considering here. Let us choose the MVA base as a 100 and the kV base as 11 kV. Okay, these values are given already in the problem statement. So now based on this we are going to find out the new kV base values. Okay, already I have told you, whenever you are finding the kV base values with respect to the generator and if the new kV base is matching with the old kV base value of the generator, then remaining all other kV base values also will retain as same values. So without any problem, you can just mark the kV base new values. So the same values will come for the rest of the components also. So now the top layer ones will be the old values and the down lane values are the new values. Now, in the previous case, what we have considered is we have neglected all these bold values because we were not using those bold values in the equation, because if the reactance or the impedance value is given in terms of ohms, the formula for the per unit impedance value is Z in terms of ohms into MVA base mu value by kV base mu value whole square. Okay. There we didn't use the old values, but here we need both the quantities. Okay. Old values as well as new values. So we know the formula for x per unit new value is equal to x per unit old value into MVA base new by MVA base old into kV base old square by kV base new square. Now here in this formula you can see we have both the new values and old values with respect to MVA base as well as with respect to kV base. Coming to the voltages, all the voltages old values and the new values are marked on the single line diagram itself. We have considered the MVA base value as a 100. Now we know that what is the MVA rating of this particular generator, transformers and the transmission line. First we are going to start with the generator. So let us mark the MVA ratings of the generator given. So for generator, the given MVA rating is 30 MVA and voltage is 11 kV. X value is 0.2 per unit. Okay, we will call these values as old values. The new values are MVA rating is 100 and you can see here all these voltages are called new values. For motor, 25 MVA rating is the old value and 11 kV is the old kV base and X is equal to 0.2 per unit. So now let us find out the Xg per unit, that is old value is 0.2, J0.2 into MVA base new value is 100, MVA base old value is 30 MVA and the kV base old value also 11 kV, kV base new value also 11 kV. So 11 kV square by 11 kV square. So if you solve this equation, we will get J0.67 per unit. In the same way, we are going to find out the per unit reactance value, new value with respect to motor. So that is Xm per unit value equal to old value, that is per unit old value is 0.2 into the new MVA base is 100 and the old MVA base is the given MVA rating of the motor, that is 25 MVA into 11 square by 11 square. So this will result into J0.8 per unit. So now let us do the same calculations for the remaining components, that is we have transformer T1, transformer T2 and transmission line. So I have taken the same single line diagram. First we are going to find out for the transformer 1. So these are the given ratings for the transformer 1. So by substituting in the formula, so we have per unit old value as a 0.1 into new MVA rating is 100 and the old MVA rating is 15 and into so if you see the old and new values, both are 11 kV. Okay, so that is your wish whether you are selecting at the high voltage side or the low voltage side. But you make sure that whichever side you will consider the old value, at the same side you have to consider the new value also. Okay, so if you are considering the LT section side, you just take both values from the LT side only. Okay, so if you are taking the HT side, you take both values from the HT side. Okay, but don't take one from LT and one from HT side. So that much you have to take care. By simplifying this, we will get J0.67 per unit. So now in the same way, if you look at the given ratings for the transformer 2, the same ratings we have. Even if you substitute and find out the reactance value for the transformer 2, we will get the same value. So for transformer T2, so J0.1 into 100 by 15 into 33 square by 33 square. that is equal to J 0.67 per unit. Coming to the transmission line, the given rating for the transmission line is the reactance value is given in terms of J 20.5 ohm per phase. It is given in terms of the ohms. That is why we have taken the formula as X transmission line in terms of ohms into MVA base mu by kV base mu square. Okay. We know MVA base mu value as a 100 and kV base mu value. Okay. This particular transmission line is operating at 33 kV. So your kV base mu value becomes 33 kV. So that is equal to J 20.5 ohm into 100 by 33 square, which will give us J 1.88 per unit. So now we are done with the calculations. We have got all the per unit reactance values on a given base quantities. Now let us draw the equivalent circuit for this given single line diagram and substitute all the calculated values in the reactance diagram to get the required per unit reactance diagram. So this is the final reactance diagram. So now let us see the second condition, that is by taking 100 MVA and 10 kilovolt as a base quantities with respect to generator again. So now let us mark the new values and volt values. So these are the volt values. Now we are choosing the MVA base as a 100 and kV base 10 kilovolt. So now you can see here volt generator value is 11 kV. But the new generating value, we are considering it as a 10 kV. So that means these two values are not same. So accordingly, you need to modify the rest of the voltages also. So if this is 10 kV means obviously here you will have a 10 kV. And here you will have 11 kV is becoming 33 kV means your 10 kV becomes 30 kV. So these relations already I have explained in the case 1. So if you have not watched that, you please go to that session and see that how we have done the conversions. Then come back to this, you will understand in a better way. So now I am marking all the new values. Now we know both volt as well as the new values. Take the single line diagram with these values. So because we need both volt and the new kV base values. First, let us find out the per unit reactance for the generator. So for that we need the generator rating. So that is again 30 MVA 11 kV X equal to 0.2 per unit. So substitute in this formula, that is Xg per unit equal to X per unit volt value is 0.2 per unit into MVA base new value is given as a 100. MVA base volt value is 30 MVA and kV base volt value. Now you can see here kV base volt value for the generator is 11 kV and the kV base new value for the generator is 10 kV. So you will substitute these two values here, that is 11 kV square by 10 kV square. By solving this, we will get J 0.81 per unit. So let us do for motor. For motor, the given ratings are 25 MVA, 11 kV and X equal to 0.2 per unit. So the per unit reactance for the motor is Xm per unit, that is X per unit volt value, that is 0.2 per unit into MVA base mu value is 100, MVA base volt value is 25 and coming to the kV base volt value and mu value, old value is 11 kV and the new value is 10 kV. Okay, so we have substituted all the values. By simplifying this, we will get J 0.968 per unit. So now let us do the per unit calculations for the remaining components, that is a transformer T1, transformer T2 and transmission line. For transformer T2, again the given values are 15 MVA and X equal to 0.1 per unit. By substituting and simplifying, you will get J 0.81 per unit. So transformer 2 is also having the same ratings. So if you calculate the values, you will get the same answer, that is J 0.81 per unit. So for transmission line, if you see here, the value is given in terms of 20.5 ohm. So the formula that we are going to use is if the X value or the Z value given in terms of ohms, that is Z in terms of ohm into MVA base new value by kV base new value square. So here the kV base new value of the transformer is 30 kV. So now let us substitute all the values. 20.5 into 100 by 30 square. So that will give us J2.27 per unit. So now we got all the new per unit quantities. Draw the per unit reactance diagram for this given single line diagram and mark all the values. So this is the resultant per unit reactance diagram for the condition 2. So now let us see the third point, that is by taking 100 MVA 32 kV at a transmission line. Okay, so now we need to calculate the new kV base values with respect to the transmission line. So now let us see that this is a single line diagram. So let us mark the old values and the new values we are going to calculate with respect to the transmission line. So now I am going to start my new values with respect to transmission line. So 33 kV is converting into 11 kV. Now 32.5 kV will become 10.8 kV. So if this is 10.8 kV, obviously your generator also will work at 10.8 kV. Primary voltage of the transformer 2 as a 32.5 kV and the secondary value as a 10.8 kV and the motor value as 10.8 kV. Now we got all old values and new values. Now let us take this single line diagram with the old and new kV base values. Now let us put the formula. So for generator we have again 30 and 11 kV, x equal to 0.2 per unit. So xg per unit is equal to J0.2 into 100 by 30. Only the precaution that we have to take care is about the voltages. Okay, for all the three conditions, this particular term will be common. Okay, so this will not change. What is the thing that it is changing in every condition is that is only the voltage values. Okay, so here also only the difference is voltage. So by solving this, you will get the value J0.69 per unit. So now for motor we have 25 MVA, 11 kV and x equal to 0.2. Let us substitute in the formula and simplifying. So that is J0.2, MVA base new value is 100 and MVA base old value is 25 and kV base old value is 11 kV and kV base new value is 10.8 square. So this will give us J0.83 per unit. Now let us calculate for transformer T1. Transformer rating is 15 MVA, x equal to 0.1 per unit. And the transformer new base value is 100 and the old base value is 15 MVA. And coming to the transformer new MVA rating is 100 and the old MVA rating is 15 MVA. And the voltage, if you see, the old kV base value is 11 but the new kV base value is 10.8 square. So simplify this, you will get J0.69 per unit. Same value will come for transformer 2 also, that is J0.69 per unit. And for transmission line, the reactance value is given as a 20.5 ohm per phase, that is equal to 20.5 into 100 by. Now the transformer is operating at a voltage of 32.5 kV, not at 33 kV. So now we are substituting 32.5 whole square, that is equal to J1.94 per unit. Now let us draw the per unit reactance diagram for the given circuit and mark all the calculated values for the third condition. Okay, so I hope everyone know how to represent the given single line diagram into the reactance diagram and how to calculate the per unit calculations for both the conditions. That is, if the reactance value is given in terms of ohms, how to find out the per unit reactance or the impedance. If the reactance value is already given in the per unit with respect to some base quantity, and if you want to recalculate those values by changing the base quantities, then how to find out the per unit values. Still, if you have any doubt, you can ask in the comment section. I hope it is clear. Thank you.